Let's solve the problem on finding the inverse z transform of x of z is equal to z cube plus z square plus 3 by 2 z plus 1 by 2 divided by z cube plus 3 by 2 z square plus 1 by 2 z. Here the ROC is z modulus of z is less than 1 by 2. We should solve this problem by partial fraction expansion method. Since ROC is inside the circle, that is less than 1 by 2, the time domain sequence what you get here, it is a left-sided sequence. Okay. Now, when you see this problem here, directly we cannot go for the partial fraction expansion method because numerator polynomial degree is same as the denominator polynomial degree. That is z cube plus z square plus 3 by 2z plus 1 by 2 whole divided by z cube plus 3 by 2 z square plus 1 by 2 z. Here the numerator polynomial degree is that is m, that is also 3, and denominator polynomial degree n, that is also 3 here. That's why since directly we cannot go for the partial fraction expansion method. So what I'll do here is in the numerator I'll take z cube common, highest degree, then you'll get that is 1 plus z to the power of minus 1 plus 3 by 2 z to the power of minus 2 plus 1 by 2 z to the power of minus 3 whole divided by, in the denominator also you take z cube common, you'll get 1 plus 3 by 2 z to the power of minus 1 plus 1 by 2 z to the power of minus 2. This term and this terms get cancelled. Here you'll get that is numerator polynomial degree is minus 3 and minus 2 first. Again it is numerator polynomial degree is greater than denominator polynomial degree here. In that case what we should do first, we should divide the numerator by denominator. We can write this equation as that is 1 by 2 z to the power of minus 3 plus 3 by 2 z to the power of minus 2 plus z to the power of minus 1 plus 1 whole divided by, how that is 1 by 2 z to the power of minus 2 plus 3 by 2 z to the power of minus 1 plus 1. Okay. Now since numerator polynomial degree is same as denominator polynomial degree, we should divide the numerator by denominator. That is right, that is 1 by 2 z to the power of minus 2 sorry, that is 1 by 2 z to the power of minus 2 plus 3 by 2 z to the power of minus 1 plus 1. Here you have that is numerator is 1 by 2 z to the power of minus 3 plus 3 by 2 z to the power of minus 2 plus z inverse plus 1. Okay, to cancel this term I should multiply this by z to the power of minus 1. 1 by 2 into z to the power of minus 2 into z to the power of minus 1, that is 1 by 2 z to the power of minus 3. Next, that is 3 by 2 z to the power of minus 1, it will become z to the power of minus 2 plus z to the power of minus 1. Next, this is minus sign, this is minus, this is minus. All these terms will get cancelled. This is get cancelled, this also cancelled, this also cancelled. Here we get 1. Okay, this can be written as x of z is equal to, that is quotient to z to the power of minus 1 plus remainder divided by the denominator, that is denominator, that is 1 plus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. Okay, let me take this part as x1 of z, that is this part has x1 of z. Okay, now x1 of z is equal to, you have 1 divided by 1 plus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. Okay, now consider the denominator polynomial. This we can go for the partial fraction expansion method. That is 1 plus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. Now its factors are 3 by 2 can be written as that is 1 plus that is 1 by 2 that is 1 plus 1 by 2 z inverse plus z inverse plus 1 by 2 z to the power of minus 2. 1 plus z inverse in these two terms you can take 1 by 2 z inverse is common, you'll get 1 plus z inverse, you'll get 1 plus z inverse into 1 plus 1 by 2 z to the power of minus 1. Hence x1 of z is equal to, you'll get 1 divided by 1 plus z inverse into 1 plus 1 by 2 z to the power of minus 1. Okay. Then x1 of z, you can factorize it by okay, x1 of z using partial fraction expansion method, that is 1 divided by 1 plus z inverse into 1 plus 1 by 2 to 1 plus 1 by 2 z inverse can be written as c1 by 1 plus z inverse plus c2 divided by 1 plus 1 by 2 z inverse. Okay. Now c1 is equal to x1 of z into denominator of c1, okay, and substitute the value of z inverse by equating the denominator of c1 to 0. That is z inverse is equal to minus 1. It is get c1 is equal to 1 divided by 1 plus z inverse into 1 plus 1 by 2 z inverse. Multiply this by denominator of c1 where z inverse is equal to minus 1. This term and this term get cancelled. That is c1 is equal to 1 divided by 1 minus 1 by 2. Answer is 1 divided by 1 by 2. Answer will get 2. Similarly, that c2 is equal to x1 of z into denominator of c2 1 plus 1 by 2 z inverse where z inverse is equal to minus 2. That is c2 is equal to 1 divided by 1 plus z inverse 1 plus 1 by 2 z inverse 1 plus 1 by 2 z inverse where z inverse is equal to minus 2. This will get cancelled. Get c2 is equal to 1 divided by 1 minus 2. Answer is minus 1. And x1 of z is equal to, you get c1 value is have 2, that is 2 divided by 1 plus z inverse, and c2 is equal to minus 2 divided by 1 plus 1 by 2 z inverse. Okay. Finally, x of z is equal to, we have z inverse plus x1 of z. Okay. Now you can write that is x of z is equal to z inverse plus, that is 2 divided by 1 plus z inverse minus, sorry, c, that c1 value is minus 1. C1 value is minus 1. This will be 1 here. That is 1 divided by 1 plus 1 by 2 z inverse. You get this small modification I will do here, z to the power of minus 1 plus 2 divided by 1 minus of minus 1 z to the power of minus 1 minus divided by 1 minus of minus 1 by 2 into z to the power of minus 1. Why adjustment I did here is because we know that z transformation of u of n, its z transformation is 1 divided by 1 minus z inverse if it is right sided sequence. Okay, if it is left sided sequence, minus n minus 1 is its z transformation is minus 1 divided by 1 minus z inverse. Since the ROC is less than 1 by 2, it is left sided sequence, and its time discrete time sequence x of n is equal to, here z to the power of minus 1. Its inverse z transformation we can find it by using impulse function. Z transformation of impulse function del of n is 1. Z transformation of impulse function del of n minus 1 is z to the power of minus 1. And so I can write this as in del of n minus 1 plus 2 into minus 1 whole to the power of n minus of u of minus n minus 1. Okay. Similarly, minus 1 by 2 whole to the power of n minus n u of minus n minus 1. Finally, I can write x of n has del of n minus 1, that is minus 2 into minus 1 whole to the power of n u of minus n minus 1. Minus of minus will become plus here, that is minus 1 by 2 whole to the power of n into u of minus n minus 1. This completes the problem.